Capstone project. Micro-hydro by Ellen Dubus. Information about the site. It is in Watauga County, North Carolina. The stream is 200 feet away from the client's house. The landowner consumes 1,070 kilowatt hours of energy a month. Now, with the right resource, micro-hydro can provide a clean, renewable source of electricity. To have a good site, you need enough head or enough change in elevation, the vertical drop between intake and turbine, to increase flow to a speed that will create electricity. Stream flow is the measure of the speed of a volume of water. Stream flow can vary throughout the year and throughout the day. Site assessment. So, what makes an ideal site for micro-hydropower generation? Head and flow are the two main variables for an ideal site. High head and high flow, or having one high and the other low works, as long as both are not low. The terrain should also have a relatively consistent slope to avoid air or sediment from getting trapped and clogging the pipe. The many trees in this area mean that there will be leaves in the stream come fall, which must be taken into account when determining intake design. The head at the site is about 70 feet, whereas the minimum stream flow is about 269 GPM, gallons per minute, so the design flow would be no more than 118 GPM to ensure that there is no habitat destruction. Technology. The technology involved includes intake, penstock or pipe, turbine, and tail race. The intake type I have chosen for the site is the open-ended pipe or flume with settling tank. This consists of a pipe diverting water from the stream that then pours onto a screen which filters the leaves and other large scrap from the water. Under the screen is a tank that fills with water, leaving the sediment at the bottom, while about midway the water is diverted into the penstock pipe that will bring water to the turbine. This intake type is the best option for this site because it is medium maintenance, low cost, about $30 to $400 depending on the quality and where you get the supplies, and the size is appropriate for the small stream. Penstock is the pipe that will transfer the water. After researching this area, I have found that winters are below 0 degrees Fahrenheit and summers may reach into the 90s. For this reason, I advise using high-density polyethylene, HDPE. Although it may be slightly more expensive than PVC, it will not freeze and it may be buried if wished. However, the joints will have to be fusion welded. Enough pipe will be needed to go the 200 feet from stream to house, plus tail race pipe, plus the initial pipe leading from the stream to the intake filter. For pipe diameter, I recommend either a 4-inch diameter pipe for the least friction loss, or a 3-inch diameter pipe. The 4-inch diameter pipe will have lower friction losses, whereas the 3-inch pipe will have around 10% friction losses. Startup costs will be less if a 3-inch pipe is chosen, although a 4-inch will save more in the long run. Turbine. With a high head of about 70 feet in mountainous Watauga County, I recommend a turbo turbine. The high impulse makes this the best choice. Impulse turbines are the way to go with high head in the area. A dump load is unnecessary because the base electricity used in the landowner's residence is more than the amount of electricity produced by the system. Resource availability. Supplies for a makeshift open-ended pipe or flume intake design with settling tank are easily accessible at a hardware store. HDPE may be purchased online, and the terrain is clear enough from the stream to the house for maintenance purposes, and the elevation decline is consistent enough for good flow. A turbine may also be purchased online if stores in the area don't provide them. Economic and fiscal considerations. Pipe materials. PVC may be purchased for cheaper, but this has a tendency to break in freezing temperatures. Pipe diameters. 3-inch is cheaper, but 4-inch will pay for itself in the long run. There is also a possible tax incentive if the landowner is interested. The local option, financing program for renewable energy and energy efficiency. This would be worth exploring for startup cost funding and may be paid back over a period of years, up to 20. But if the landowner wishes to install immediately, then this process may be too slow to bother with. Policy considerations. There is a federal regulatory policy that may apply called Interconnection Standards for Small Generators, but this is only if the landowner wanted one day to link up this micro-hydro system to the grid. So currently it does not apply to him or her. There is also a state regulatory policy that may apply, net metering. This is if the system is already connected to the grid and excess energy may be sold back to the electricity company. This may be useful if the client does not live in the residence year-round, but somehow maintains the micro-hydro system. There are no federal, state, or local policies that would apply to the landowner's request of a micro-hydropower system in Watauga County, North Carolina, other than any potential visual restrictions put in place by local authorities in the client's residential area. This is a good reason to use HDPE for pinstock, as it can be buried. What I recommend. On the Excel spreadsheet on the following slide, you can see the hourly median flow, design flow of 118 GPM, the head of 70 feet, the 826 watts of power generated, and the 0.826 kilowatts per hour of energy produced. On the second Excel spreadsheet, you can see that the established capacity factor is either 95% or 55%. By multiplying this by the micro-hydroelectricity generated of 0.826 kilowatt hours, we get the actual kilowatt hours of energy generated. As a capacity factor of 95%, the energy generated is 0.7847 kilowatt hours. This occurs during 8 hours, totaling 6.27 kilowatt hours. With a capacity factor of 55%, the energy generated by the system is 0.4543 kilowatt hours. This occurs during the other 16 hours of the day, totaling 7.27 kilowatt hours. The total energy consumed by the household is powered fully by the micro-hydro system for 5 hours of every day. The total energy generated per day by the system is 13.55 kilowatt hours. With 30 days in a month, this results in 406.5 kilowatt hours per month and 4,878 kilowatt hours per year. The client's energy usage is at 1,070 kilowatt hours per month, which means that this micro-hydro system supplies 38% of the total monthly consumed energy, seriously reducing electricity costs for the client. So, what I recommend a micro-hydropower system with an open-ended pipe or flume intake, 4-inch diameter HDPE pinstock, a turbo turbine, and possible consideration of the local tax incentive program.